All right. So I think this is going to be a little bit fast because we have about 30 minutes before they throw us out of the building. Um, so I'm going to tell you guys the story of how we basically moved from supporting a single platform using one set of tools at Netflix to supporting multiple platforms using the same set of tools, but with a little bit of an additional layer on top of that. All right. We really try not to reinvent the wheel as much as we can. There's just too few of us and too much work. All right, so I'll start with some background about Netflix, just a little bit. As I'm sure most of you know, Netflix started in the DVD shipping business. Basically, you could go on a website, you choose your favorite DVD, that DVD would get shipped to you. You'd watch the DVD, you'd send it back, and then the next item on your queue would come next to your house, right? And that was basically it. That was in '97. And back then, I'm sure we didn't have fancy things like the cloud or Amazon or microservices or any of that. And so Netflix, just like many other companies, had a monolithic Java app using an Oracle database and on a data center, which is it's not ideal nowadays, but that's what we had back then. And if you look at like all the open source offering we have today at Netflix, you might be tempted to think that we're still like really mostly Java, maybe monolithic still. And here we have a couple of examples in the back. We have Nebula, which is our build system that's based on Gradle. We have Spinnaker, which is our CI/CD, also open source. Hystrix, which is our fault-tolerant communication layer. Everything is built on the JVM, so Java and Kotlin and Groovy. But the fact is, if you look at the actual stats and what our code base looks like, you'll see that we've actually turned polyglot, right? You see there's a bunch of, if we focus for a second on the JVM stuff, we have a ton of Java, Groovy, and Scala, but it's not really the vast majority at this point. We also have this big blob at the top for JavaScript, and that includes both UI and Node apps. We have Python. A lot of our data engineers, and which is something that we're investing more and more time and money into, like to use Python. It's the data science language, and so we have a lot of that. And Tiny Ruby, you see there at the top, comes from our studio effort. This is a relatively small team that we have, but it's growing pretty significantly over time. That's the people that basically work with our studios and help us produce the original content. And I'm sure you saw we have more and more original content. These guys are going to become much, much bigger. So we asked the question, what happened? How did we turn from Java to Polyglot? How did this happen? And we think basically there are two main reasons for this. First, at Netflix, one of our core values is freedom and responsibility. I'm sure you've heard this before. Really briefly, what this means is that every team is able to pick whatever technology makes sense for them, right? We do have centralized teams. We do support stuff centrally, but if, for example, or for whatever reason you want to use Elixir, go ahead. You can go ahead and do that if it makes sense to you. The only caveat is that you also have to support it, right? If you choose to go with something that's non-standard, that's not supported by a central team, it's on you to support it, and that goes from building, testing, deploying, monitoring, the whole way, right? So that is that. The second thing that happened is that in 2008, we moved from the data center that we talked about to Amazon, to the Amazon cloud. And as we were doing that, we were also kind of picking apart the monolith and basically creating small microservices. And like in the process, some people realized, hey, why not just write this in Go or in Groovy or in whatever else? And so it was easier to kind of switch to different languages. And that said, we also have the concept of a paved road, and that's actually where my team comes into the picture. Paved road means that we as a team try to find the road most traveled or the technologies that are being used the most. And then we kind of try to formalize it using a set of best practices and some tooling, and we make it super easy to do the right thing. And so as a result, most people, because this is the path of least resistance, most people actually go with the paved path, right? There are always exceptions, and there's always snowflakes, and people will always do crazy things, especially at Netflix. But the majority of people, the majority of people actually use the paved road, which is great for us. Okay, and what does that paved road actually look like? We identified five, common development stages, and I think it's very similar to what everyone else has experienced everywhere else. First, we need to initialize a project when we start the lifecycle. What does that mean? In our case, we need to create a Git repo that's Bitbucket there. We need to create a Jenkins job for CI. We need to do the deployment pipeline in Spinnaker, which is our CI/CD tool. We need to set up monitoring and alerts, and there's a bunch of other stuff. And basically, getting all those things to communicate with each other with webhooks and whatnot. A lot of work, but this is phase one. Second step is once you actually have all the things kind of talking to each other, you want to start writing code, right? So you want to build, you want to get dependencies, you want to test, you want to do all sorts of things. And because we're mostly a JVM shop still, like maybe 50%, the vast majority of teams use Gradle still, but we have NPM and we have Yarn now and Go and SBT, and there's a bunch of other stuff that people are using. Next is obviously CI, so you have to integrate your code. You want to make sure it actually runs, not only on your computer. That is still an issue, even for us. People still say it works on my computer. Um, we have Jenkins for the internal stuff. We have Travis CI. We actually do like Travis for the external stuff, mostly the open source stuff. And then we have Docker for more specialized things, like if we have high performance C++ code or something that requires like a system level dependency, then we actually do this in a specially crafted Docker container, right? Because our Jenkins slaves don't normally have all those tools pre-installed. Next, what we do is we package everything. Our contract for packaging the component, the artifacts, is to package in a Debian package, right? So we take the compiled code or whatever is the end result of the build, and we create it into a Debian. What we then do with the Debian, unrelated to this stage, is we take it and we bake it on top of what we call the base AMI. It's the Amazon machine image, and then that would be the immutable unit of deployment that we then use in Spinnaker to scale up or scale down, right? But the most important thing is that we have a Debian that we can later use for the rest of the process. And then lastly, we have our binary repository. That's the thing that takes our Debian, hosts it. In our case, we use Artifactory, but you could use anything else. Doesn't really matter. All right. So really briefly, we have a pretty standard pipeline, right? We initialize, we build, we integrate, package, and publish, right? Pretty standard. And because traditionally Netflix has been, historically Netflix has been a Java shop, then we've provided all those tools through Gradle plugins, right? So when we tell people to develop, we actually tell them, hey, run Gradle build. When we tell them, you want to package, you run Gradle build deb using our OS package open source plugin. When we tell them to publish, we tell them use the Artifactory plugin that comes with some, metadata and some credentials and some, glue code basically. But that's basically what we say, and it's all based on Nebula. And so if this is interesting to you, by the way, if you want to learn more about how Netflix builds stuff, then there is a really excellent blog post out there. Don't worry, I'll share this later, I promise. But yeah, it's really good information in there. So, we got to ask, is this really good enough? We have a Ruby developer. The Ruby developer, uses bundler. We have, uses gems. Does it make sense for us to ask the Ruby developer, hey, you now need to use Gradle to create the Debian because that's the only tool we have for you? Does it make sense, for Node developers who are only used to having a package.json and npm to start running Gradle? And I think we all would agree that this is not really great, right? First of all, you have too many configuration files in there, and typically, developers who come from non-JVM background, they don't really care, don't really want to know anything about Gradle. And more specifically, this causes a lot of problems, specifically because developers that don't have the experience. And so as a result, they try to find the path of least resistance. They go look elsewhere in the code, in our Git repositories and see who else has done something similar. So they copy and paste. And obviously they copy and paste the wrong thing. And so they run into issues. And so, the build breaks and then we have to help them. And it like goes on and it's really, really error prone. And even if people do know the background for Gradle and know how to operate Groovy and know how to do that stuff, it still sucks. It's still a really bad user experience, right? I mean, who would want to use Gradle if they don't have to? And last, sorry if there's any Gradle fans in here. Uh, uh, So, and last thing, and I think this is important, like before we had any automation, any solution in here, like initializing a new app was a nightmare, right? You had to basically create the stash repo, you had to create Jenkins, you had to create Spinnaker, you had to create alerts, you had to make sure everything works together. It was just a nightmare. One of our teams basically said, it could take us up to 2 days to get just a simple microservice up and running. And that's crazy, right? Because we have the cloud. It's just a matter of, standing up an instance. Why is it so hard? And so obviously because it's also lengthy, it's also very error prone. And even if you follow the instructions to the dot, there's always a chance of getting it wrong. And so it wasn't great, right? It wasn't ideal. So we talked to a couple of teams and they told us, you know what? We don't want this Gradle thing. We want native tooling. We don't want to have boilerplates. We don't want to copy paste everything. So what is the solution? How did we fix this? Did we fix this? Uh, uh, so basically we realized that all platforms share the same kind of life cycle, right? The same 5 stages that we talked about before are common to everything. That applies to Ruby, that applies to Python, applies to Node, applies to Java. Everyone needs to go through the same process. And the second thing we realized is that the API per se between the different stages is very well defined. So for example, when we want to package our code, we know what needs to come in, artifacts and compiled code. We know what needs to come out, that's a Debian, and something needs to happen in between. We don't really care how, but something needs to happen, right? So that would be the API. The second thing we realized is that every project comes with its own unique metadata that's really only unique to it. Like for example, what system dependencies it has, how does it actually build itself? What the version is, what the name is, and so on and so forth. But stuff that's really unique and we cannot really kind of apply to everything else. And with that, we came up with Newt. Newt stands for Netflix Workflow Toolkit, and believe it or not, we actually have another app that's its sole purpose is to come up with names for other apps. So you just dump in. Yeah, we might open source that. Uh, so we basically put down like a list of things that we want this thing to do, and it just came up with Newt. We like it because it's short. And this is the logo. Come later, we have stickers for your laptops. All right, so what is Newt? Newt is a multi-platform CLI tool that manages application lifecycle. Wow, this is a lot. But it's really very simple. What it does is it allows you to run the different stages of your build using like newt init, newt build, newt test, newt package, and newt publish, right? That's it. What's interesting about this is it executes every one of those stages in an isolated Docker container. And I'm going to assume everyone knows what Docker is because we just had a whole talk about Docker, right? So no need to. Okay. All right. So isolated Docker container. Essentially, we ship all of our dependencies, all of the glue code inside of containers, and it gets executed in there. Let's see an example of what this looks like in Newt. When you want to initialize an app, you basically run newt init and you specify the app type. This is sort of a concept of a template, right? What happens is Newt goes and sees, do you actually have Docker installed in your machine? If you're on a Mac, it uses Homebrew to install Docker for you. If you're on Linux or on Debian, it uses the app to install it. If you're in Windows, we don't support it yet. Was that clapping? Slow clapping? But we will. So once it installs Docker, it downloads a pre-baked container onto your computer that comes with the tools you need to initialize the project. In this case, it comes with Yeoman, which is a code generator that's based on Node, and obviously it needs to have Node in it and npm and our custom generator. We mount the workspace from your computer to the container. It runs its thing. It creates all the things that we just talked about that are super error prone, finishes, and then throws away the container. So as far as the user is concerned, they didn't even need to know it was Yeoman. They didn't have to know there was Node. They didn't need to install anything. They just needed to run newt init. Okay. So is this better? We want to ask, and I think it is. First of all, it's much, much faster, right? We went from 2 days to 15 minutes in one example. Much, much better, right? You do less work. You're a lot less likely to make mistakes. You don't have to keep documentation up to date. It's been working great. And again, it's a lot less error prone because there's just a lot less to do. The second thing that is interesting here is that we now just have a single tool for development, right? If previously, we had asked developers to install Gradle and the Java runtime and Node and npm and maybe a Node version manager and whatnot, we now have a single tool. The single tool is called Newt, and Newt is able to bootstrap everything for you based on your app type and based on the command that you just ran, right? And we'll see in a little bit why this is actually very interesting. We didn't realize that at first. Okay, let's see a different example. This one around packaging. So when we run newt package, as you recall, we basically take the artifacts, we created Debian out of it, right? In this case, we're not using Node anymore because we have an implementation. We have an existing implementation through Nebula. So what we do is we download the container that comes with Java and Nebula, which is again our Gradle distribution, and some custom wiring code, and we execute it against the workspace. The artifacts turn into a package. The container goes away. The user didn't even have to know this was Gradle, right? And again, especially our Node user or Node users were especially happy to get rid of Gradle in that respect. And I think maybe important to note here is that the method by which the Debian gets created, it becomes irrelevant. It's just an implementation detail, right? And it's important to highlight this again. Why is that really important? Because once you don't even think about Gradle, once you don't even have to think about all the glue code and how things work, it's lower cognitive load, right? You can focus on the business logic, you can focus on the thing that really matters, and you leave the plumbing to the containers. They'll deal with it, right? And the second thing that's it's good for us as a centralized team, but it's also great for the org. We have really good code reuse. We don't have to re-implement Debian packages in Node or in Ruby or in Python or in whatnot. It kind of just works as long as the API remains the same. Okay. So again, a quick recap. We did an init through Docker using Yeoman in a container that came with Node. We did CI using basically a builder type container. We did package and publish using Java and Gradle-based container that was using our open source plugins. And we're left with the develop phase. How do we build? How do we test? How do we get dependencies? And it wasn't very clear at first how to get this done, right? Because if any of you have worked with containers for any sort of development, it's not trivial to get everything working. We have some representatives here from other teams at NFX that would be able to tell you a lot more about that. So what we ended up doing was to introduce a new command called newt exec. And what this does is it looks into your configuration file that comes with the repo and sees what kind of versions you need. It's very similar, I think, to what you guys have here. It says, all right, I need node 692. And whenever they run newt exec node, it goes and bootstraps node into your computer, kind of like NVM would do or RBN for Ruby, and then execute it for that specific workspace. So in other words, you're always guaranteed to run the right version of the runtime if you have newt installed and the .NET YAML is configured correctly. And that would apply, of course, to local machine and to, on Jenkins and anywhere else you want to run it, across platforms as well. This can actually be optimized a little better if you play with bash aliases and you replace node with newt exec node, but maybe we could get into that later. All right, so I wanted to do a demo, but I don't know if it's going to work. Let me try. Okay. All right, so I wanted to show you what newt init looks like, but it's going to be very awkward. All right. Can, all right. Can you guys see more or less what this is? All right. Yeah. How do you like the ASCII? It's the most important feature. So basically, when as you can see on the as you can see at the top, we run newt init, we specify the app type, and it basically tells us, it asks us a couple of questions, right? Do you want to create it here? Do you want to create a stash or a Git repo? Do you want to create Spinnaker for CD, Jenkins, so on and so forth. I don't know if my connection here is good enough to actually do this. But this is how it works. Okay. Can you still see this? How's this? Yeah? All right. I can't even see what I'm typing. All right. So this is one example of a project that uses Newt right now. It's a Node project. It's actually a TypeScript project. And you see here it's of type node AMI deploy. It's got these tool versions. And it's got a build step that says, whenever you build this, run npm run build, okay? And what actually happens here, because Newt understands this app type, is it creates a specialized container that comes with all those tools bundled inside. It's not as sophisticated. We don't pre-cache everything. We create it on the fly, but then we cache it after we create it. And then it runs npm run build. I guess I could skip the part where it actually builds, but but trust me, when I run newt build, it actually happens in a container. Maybe I'll just do this. All right. So you can see more or less here that it actually gets a builder. This is Docker output, but the rest is just whatever happens in the container, right? I don't care. I don't even need to have node or npm installed on my computer. It all happens in the container. And obviously the same thing can happen on Jenkins, right? It's all the same. It's the same container. All right, I'm good. Okay. All right, so so as you saw, we basically were able to leverage the existing set of tools we had for Gradle to basically enable other app types. We were able to do this for Node, for Python, for Ruby, and there's a bunch of others. There's a bunch of other types that we've implemented. But after kind of experimenting with customers and speaking with different teams, we realized, hey, this approach actually helps solve other problems as well, right? First of all, and this is a problem I think centralized teams would really understand, is that developers never have the exact same environment, right? So, and they often have problems with, maybe they have the wrong Java version or the wrong Gradle version, or maybe they have a system dependency locally that they don't have on Jenkins. There's just a bunch of those issues. And when you basically do everything in containers, that problem just goes away, right? That's no longer an issue. The first question when someone, comes to Slack and asks us, this is not working, the first question is, did you run it in a container? Yes or no? If the answer is no, then, well, we know what the problem is. If the answer is yes, then, not as good. Second thing that we realized is that we are also the providers of the Docker containers, and so maintenance is kept central. What this means is that we no longer have people doing random things in their own, snowflake environment. We know everything is mostly, for most people, is mostly the same. And so as a result, if one person gets an error, it's more than likely that everyone else will see the same error. So what this means to us as a centralized team, we get reports really early and we fix them for everyone fairly fast, even before most realize there is an issue. And that's great. And so far it's been working pretty well, and we hope to do it for a lot of other app types as well. Another interesting thing that we realized is that now that we have a single tool, we also have metrics for everything, right? We know how long it takes people to build. We know how many people test, how many people don't test. We know, uh, we know what type of apps are being deployed. We know what technologies. There's really a lot of information that we can learn, and that's really just, thanks to the fact it's using a single tool. Previously, people used, Node, and they use npm, they use bundler and other stuff, and it was really hard to kind of track everything. Essentially, we would have had to build metric recorders for all the different platforms. Now we don't have to anymore, which is great. And finally, because Docker runs everywhere and Newt is written in Golang, we also get the benefit that this works everywhere, right? It works, well, and by everywhere, I mean on a Mac, on a Debian. Still doesn't work on Windows, but as soon as we hire people, I will we'll do Windows as well. There's just two of us, by the way. So, all right. So again, a quick recap. We Once we realized we had the well-defined stages, we had a pretty well-determined API, we were able to reuse a lot of our information by using isolated Docker containers. And by doing so, we also streamlined the development experience for everyone. Everyone is kind of doing the same thing, and the expectation is that Newt build would do the right thing, right? And even if you move between teams, even if you use a different technology, you get more or less the same experience, even if it's a completely different set of tools. All right, so so far Newt is how old? Is like 1 year old, maybe 2 years old, year and a half. So Newt's a year and a half old. It's already being used by about 600 developers, which is, and considering the fact that we can't force anyone to do anything in Netflix, it's actually not bad. And we constantly keep coming up with new use cases. How much time do we have? 10 minutes? Oh, it's perfect. It's more. It's more than I thought. So one of the interesting use cases that we ran into has to do with documentation. And I don't think we have enough time to dive into the technical details, but remember how we talked about freedom and responsibility? So with documentation, teams are free to choose whatever documentation engine they want. And so naturally, as a result, we have every type of documentation. At Netflix, we have MkDocs, we have Confluence, we have Stash Markdown, we have Google Docs. We really have everything, which is great for the teams. I mean, if they know where to look, but if you don't know where to look, you're out of luck, right? And that's a pretty hard problem, considering that we cannot really change the culture, right? It just doesn't work. So then, we thought about it a little bit, and we saw that a lot of teams really like to use MkDocs. MkDocs is a Python-based toolkit that takes Markdown and converts it to a really nice static website, right? How many people have seen this before, MkDocs? Oh, wow. Sphinx, maybe? No? All right. Yeah, so about the same. And people really like it because it uses Markdown, and Markdown is not Confluence syntax, so that's already good. And it also lives in the same repo. So when you do your PRs, you can do the documentation together with your actual code changes, which is great. The problem was that it was based on Python, and so unless you're a Python developer, you're unlikely to install MkDocs. And so we solved this through Newt by basically abstracting out the tooling aspect of it. And again, I need help. All right. Okay. Is it big enough? Yeah. All right. So one of the things we exposed through Newt is something. Actually, you know what? Let me just show you. So this is the same project, the same TypeScript project we talked about before, except this is a subdirectory called MkDocs, and it's got a different app type, a different newt YAML. What this says is this is actually now a documentation thing, and it basically exposes more commands. One of the things we can do here is what... It's not working. Does it say serve? Is newt serve. What this does is it bootstraps the container that comes with the Python and MkDocs tooling. It starts up a live server that takes the markdown that we have on the file system and converts it to a static website live. Okay? It's going to be challenging. Woohoo. So this is what the site looks like. Now, what I could do is I could edit and then you see it gets updated straight away. Again, I have 0 Python on my computer. I don't care about Python. I only care about the docs. But given the right app type, given the right abstractions, I can basically have a really good development, really good documentation experience available to me. Another cool aspect that we have here is we also have, I'm not going to do this, but we have newt publish. Again, in the context of this app type, what this does is it takes the documentation bundle and uploads it to our central service using, again, a specialized container, and then drives it through Elasticsearch, so everything is searchable. So it doesn't really matter. They could use MkDocs, they could use whatever they want. It would still go through our service, be indexed, and available to everyone else. All right, so that's just one option that you could do with this type of mechanism. Where's my thing? All right. All right, so as I said, there's a lot more to do. We're currently working on open sourcing this thing. Right now it's kind of coupled to the Netflix infrastructure, but hopefully we'll be able to decouple everything and make it open source so that other people can benefit and maybe potentially also contribute. Yeah, and that's pretty much it. Here's the link I promised from before. We do have stickers. Feel free to grab them. And yeah, if you have any questions, or do we have time? Yeah, lots of time. 5 minutes. Yeah.
Not be directly related to newt, but kind of about the AMI-based or Debian-based deploy process. Do you guys bake in config sort of info into those packages too, in the sense that if I want to just tweak some sort of setting, it goes through the same sort of pipeline, or is...
Sure. Yeah. So the question was, do we allow to alter our base AMIs with custom configuration? Is that accurate? Yeah. So the answer is yes. We have a set of, our base AMI is what we'd call best practices. We have a team that, comes up with the base image and with what they think is the best approach. But you don't have to use the base AMI. And if you do use the base AMI, you can always reconfigure it. You could put stuff in Etsy. You could run, post-install scripts. There's really whatever you want to do, you can do. But again, freedom and responsibility applies, right? If you screw something up and it dies in production, in 2 a.m., they're going to call you. They're not going to call the base AMI folks, which works for some people. So the question was, how do we distribute newt itself? Newt is a single, so it's a Golang binary. It's a single binary. It has 0 dependencies. And we basically ask people to curl bash. You're familiar with that, I'm assuming. We ask users to curl bash newt, and then every time it runs, it updates itself. It checks against the central service, and if it sees that there's a new stable version out, it downloads the delta, it patches itself, and then they get the new version. And so we had this, debate internally. Do we actually want everyone to be always on the latest, or do we want to, support older versions? And we realized that it makes more sense to always push people forward and fix bugs as they go instead of just kind of pin back. It's very similar to the way Chrome works, I guess. It's been working for us. Yes.
Hi. Does it integrate with IDEs?
Does it integrate with IDEs?
So like if you're have a specific version of the JDK.
Yes, but it really depends on the app type. So in some cases, it's easy. In some cases, you have really good integration, especially if you use IntelliJ, then they have like container-based integration. It works pretty well. In some cases, like for example, if you use Node and your code is inside the container, then file watch is not always great. It really depends. But ideally, yes, it should work inside IDEs as well. Yes.
Templates that you have for like the kind of base, how do people discover those? How many do you have?
That's not going to work. So there is a command called newt app types, and it basically prints out a table with all the things that we have, all the apps that are centrally supported. And there we have a short description and a Go link or a short link to the documentation. So you could learn about it there. But we have, I think, closer to, I want to say 20-ish. The thing is that it could be very, very custom for specific teams. Like some teams take our Node app and they customize it like crazy because it makes sense for them, but only for them. And sometimes we have things that are global for everyone, like the MkDocs stuff, right? It just works. We do encourage people to create their own app types if it makes sense. So an app type or a template is defined as a set of YAML files, essentially, right? Basically, the way it works is you inherit from a template, and then you can override it with the .NET YAML that you have in the workspace. There's also some stuff around templating and creating like the default stash repo and the Jenkins jobs and Spinnaker, but mostly it's just YAML files. Yes, please.
Does this work with mobile, or is that more kind of on the unicorn side?
Mobile in what sense?
Like iOS app, Android app, something like that.
Not yet. So the question was, does it work with mobile? And the answer is no. not yet. Anyway, we didn't. So we weren't asked for this type of support, but if it gets there, then I don't even know what that would entail, to be honest. Out of time. Last one, I guess.
Yeah, we're working on Node.js and fixing some issue about the heap dumps and performance, and the Netflix story about the frame graph has been really helpful.
Sure.
So, and do you keep track of the performance and the heap size within your CI/CD chain somehow, that when the new code comes in or the new PR is built, how it's affecting the performance or the memory?
So the question was, do we track performance of builds over time, right? In our CI/CD
pipeline. Yeah.
I think that varies greatly between teams. Some teams put a lot of effort into making sure performance is stays the way they want it to be, and some teams don't really care. Like if it's an internally facing tool, then if the build takes 5 minutes, who cares? If it's something that is external facing and performance is a super issue, then yeah, for sure. Oh, I guess one more question. We're not kicked out yet.
So do you run a newt package or newt build? Do you run that in CI, or people run it on laptops, or both?
Question was, where do we run newt package build? So it really again depends on the team. Some teams like to run newt all over the place, but I think the majority of newt users actually run it directly on Jenkins. All right, thank you.